Dear students, we are on the topic solutions. Let's continue with solving numericals where we relate various concentration terms. So in this session, we will relate first the mass, percent and mole fraction. Okay? Let's understand this. Let's understand how to relate these two concentration terms by solving a numerical. The mole fraction of benzene in a solution with toluene is 0.50. That is the mole fraction of benzene. So you have a mixture of benzene and toluene. Alright? Determine the mass percent of benzene. Let's understand this first. Mass percent of benzene implies 100 grams of the solution. 100 grams of the solution contains what mass of benzene? So this contains what mass of benzene? What mass of benzene? X grams. Okay? This is what we need to find out. So X grams of benzene are present in 100 grams of the solution. So we need to find out what is the value of X. Alright? So how do we go about solving this question? Now, what is the formula for mole fraction? Okay, mole fraction of benzene, let's focus on benzene, that is equal to the number of moles of benzene divided by the number of moles of benzene plus the number of moles of toluene. Toluene is C7H, you've got 8. C6H5CH3, correct. C7H8. You are provided with information that the mole fraction of benzene in a solution is 0.50. So before we continue with that formula, let's make an assumption. So 100 grams of the solution contains X grams of, we already discussed that, benzene. So the mass of benzene in 100 grams of the solution is X grams. So what will be the mass of toluene? 100 minus X grams will be the mass of toluene, C7H8. Okay? So with this information, let's substitute in this formula. We know the molar masses of these compounds. The molar mass of benzene being 78. Molar mass of benzene being 78, and this will be 12, 7s are 84 plus 8, 92. 92 is the molar mass of toluene. We need all this information to substitute in this formula. So that is equal to, so mole fraction of benzene is C6H6 is 0.50. That is equal to, number of moles of benzene would be mass of benzene divided by the molar mass of benzene, which is 78, divided by X by 78 plus 100 minus X, the mass of toluene, by the molar mass. Okay? Now you solve for X. So we get the value of X as 45.9 grams. Alright? So we get the value of X as equal to 46 or 45.9 grams. Okay? So we got the mass of benzene. X stands for the mass of benzene. So what is the mass percent of benzene? Mass percent of benzene therefore would be the mass of benzene 45.9 by 100 grams of the solution, and that is equal to 45.9%. 45.9% will be the answer to this question. So all the steps have been neatly presented here. Okay, and you arrive at the mass percent of benzene as 45.9%. So what you have to understand here is, you first write down the formula for the mole fraction of benzene. Okay, and then once you see that And once you see that the final question is mass percent, understand that in 100 grams of the solution, what is the mass of benzene? So it's clear that 100 grams of solution comprises of benzene and toluene. And then one of the masses can be X, the other will be 100 minus X. Then you know how to go about solving this, and finally you arrive at the mass percent. Okay? Now let's connect molality and mole fraction. The earlier one was mass percent and mole fraction. Now molality and mole fraction. There is a shortcut formula represented here which will be very useful when you solve questions in competitive exams. But right now we will solve the question conceptually. Okay? So here is the question. An aqueous solution contains 0.150 mole fraction of glucose. Calculate the molality of the solution. So you have a mixture of water and glucose. You are provided with the mole fraction of glucose. So what does that mean? Mole fraction of glucose, you know that mole fraction of glucose plus mole fraction of water is equal to 1. So if the mole fraction of glucose is 0.150, the mole fraction of water would be 1 minus 0.150, which is 0.850. Okay? So what does this imply? This implies that 1 mole of the solution, 1 mole of the solution contains 0.150 moles of glucose, 0.150 moles of glucose, okay, moles of glucose plus what else? 0.850 moles of water. Okay, that is what this means. When the mole fraction is 1, when the sum of the mole fractions of the two components is 1, it implies that 1 mole of the solution contains 0.15 moles of glucose and 0.850 moles of water. So you have the number of moles of glucose now, 0.150, and you have the number of moles of water. Correct? So number of moles are ready. Now what do you need to find out? Let's write down the formula for molality of the solution. Okay? So molality of the solution is equal to number of moles of the solute. What is the solute here? Glucose. Number of moles of glucose, right, divided by the mass of water. Mass of water, if it is in grams, therefore into 1000, the numerator into 1000. Okay? Now how do we find? We know the number of moles of glucose. What is the mass of water? Mass of water would be the number of moles of water into the molar mass of water. Okay, so that is the mass of water in grams. So what is it? That's equal to 15.3 grams. So here we write 15.3 grams. So now we have all the data required to find out the molality. So what is molality equal to? Number of moles of glucose. What is that? 0.150 into 1000 divided by the mass of water, which is 15.3. So what is the final result? So all the calculations have been presented neatly here. The final result is 9.8. Final result is 9.8. Okay. So let's quickly look into all the steps which have been neatly presented here. So first we know that the mole fractions of glucose plus water is equal to 1. What does that mean? 1 mole of the solution contains 0.15 moles of glucose and 0.85 moles of water. What is the formula for molality? Number of moles of glucose into 1000 divided by the mass of water in grams. Number of moles of glucose is 0.5. Okay, let's find out the mass of water in grams. Number of moles of water into the molar mass of water, which is 15.3 grams. right? So now what is the final substitution? Molality is equal to 0.15 into 1000 divided by 15.3, which is equal to 9.8 grams. So by solving these numericals, I hope you've understood how to relate the various concentration terms.